This is our video for Wednesday, May 6th for pre-cal. Today we're going to talk about geometric sequences. You'll need your books open to page 576. Just a reminder, on Monday we talked about arithmetic sequences. Tuesday, the sum of arithmetic sequences. Today we're going to talk about geometric sequences. Tomorrow we're going to talk about geometric series, and all the homework is due Thursday at midnight. And we'll have a quiz on Friday over 8.2 and 8.3. So last couple of days we've been talking about arithmetic sequences. Arithmetic sequence is where something is added to get to the next number in the term. Geometric is going to be different. A geometric sequence is a sequence in which the ratio between consecutive terms is constant. This definition, if you look back at the definition for arithmetic, it's almost word for word, except with arithmetic it said difference, and with geometric it says ratio. Remember that a ratio is a comparison between numbers. Some people think of it as a fraction. And so if we have 5, 10, 20, 40, and you look and you think, oh, what's happening? 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40. And so it's being multiplied by 2. A ratio is a comparison, and the way we're going to find the ratio is 2 for this one, is you are going to divide a term by its preceding term. That sounds kind of funny, but it's basically, last time we were looking for the common difference, and we would take the term behind and subtract the one in front. We're going to take the 10 and divide it by 5 and get 2. 20 divided by 10 is 2. 40 divided by 20 is 2. So that common ratio is 2. So in simple terms, a geometric sequence is where a number is being multiplied to get the next consecutive number. Arithmetic, a number is being added, common difference. Geometric, a number is being multiplied, which is that common ratio. So if you turn to page 582 and we look at the section 1 through 10, determine whether or not the sequence is geometric. If it is, find the common ratio. So if we look at number 1, we have 5, 15, 45, 135, so forth and so on. And they want us to determine if it is geometric. So 15 divided by 5 is 3, 45 divided by 15 is 3, and 135 divided by 45 is 3. So this is geometric, and the common ratio is 3. If we look at number 3, we have 6, 18, 30, 42, so forth and so on. 18 divided by 6 is 3, 30 divided by 18 is not 3, and 42 divided by 30 is not 3. So this is not geometric. But if I look at it, 18 minus 6 is 12, 30 minus 18 is 12. This is arithmetic, and the common difference is 12. So they're going to be mixed up. And on our quiz on Friday, they're going to be mixed up. So kind of pay attention. Geometric is a common ratio. Something is multiplied to get the next number. Arithmetic, we have a common difference. Something is added to get the next term. Now, just like with arithmetic, there is an explicit formula that will work for all geometric. So let's go back to 5, 10, 20, 40, so forth and so on. And let's think about what's happening here. This is 5 times 1. 10 is 5 times 2. 20 is 5 times 4. 40 is 5 times 8. We've got 2, 4, 8. So this is 2 to the first power. 4 is 2 squared. 8 is 2 cubed. And 2 to the 0 power is 1. And so what's happening here is they're taking 5, which is the first term, and they're multiplying it by a multiple of 2. And that common ratio was 2. So our explicit formula for geometric, if we want the nth term of a geometric, we're going to have to know the first term. We're going to have to know that common ratio r, and we're going to multiply the first term by the ratio with n minus 1. So here we were looking at the fourth term, but we weren't multiplying it by 2 to the fourth because we started with 5, and we multiply the 5 by 2. So we multiplied by 2 one time, and then we multiplied by 2 two times, and then we multiplied by 2 three times. So the fourth term is being multiplied by 2 to the third power. So if we want the, let's say that we wanted the 10th term, then we would take the 5 and we would multiply it by 2 to the 9th power. 2 to the 9th power. And I've lost my calculator, so I'm not sure what that is, but that's how you would find the 10th term. So if we look at number 19 on page 582, it says write the first 5 terms of the geometric sequence, find the common ratio, and write the nth term. So they're telling us that the first term is 64, and then they're giving us that weird notation again. A sub k plus 1 is equal to 1/2 ak. So this is our recursive formula that we talked about last week, and the recursive is helpful actually in figuring out what the common ratio is. It's going to be the 1/2, but it can't tell you any term out in the future. It can only tell you the one directly behind. So what they want us to do is to write the first 5 terms. So we've got 64, and then we want half of 64 is 32. Half of 32 is 16. Half of 16 is 8. Half of 8 is 4. And let's see, how many they want? They want 5. 1, 2, 3, 4, 5. So that would be the first 5 terms. And then it's find the common ratio. So that common ratio was 1/2. And then they want us to write the nth term of the sequence. So they want the explicit formula. So I'm going to use this formula right here. And so the nth term would be the first term, which is 64, times that common ratio of 1/2 to the n minus 1 power. So the recursive, again, it tells you what the ratio is, but it doesn't, you can't use that to find the 100th term. But this, the explicit version, could be used to find the 100th term, the millionth term, any term in our sequence. So that's why the explicit is more useful. All right, let's look at number 25. Find the nth term of the geometric sequence. All right, so they want the 10th term, and the first term is 4, and the ratio is 1/2. It won't always be 1/2, just in these couple of examples. And so our formula is n minus 1, so this is going to be to the 9th power. And so we're going to have our 10th term is going to be 4 times 1/2 to the 9th power. And actually, again, I've lost my calculator over here, but I do have the answer, is 1 over 128. So the 10th term of the geometric sequence that starts with the number 4 and has the common ratio of 1/2 would be 1 over 128. Now let's look at one more. They try to make it a little more interesting. Let's look at number 31 real quick. They want the 11th term. They're telling us the first term is, I'm looking at the wrong problem. They want the 6th term, and they're telling us that the second term is negative 18. The fifth term is 2/3. Okay, and they want to know the sixth term. All right, well, if we knew the recursive formula, we could find that really easy, but we don't. So let's do a little work here. So I'm just going to make a space for our terms. So we're looking for this term. We don't know the first one. We know the second one is 18, and we know the fifth one is 2/3. Okay. Now, this is geometric. They told us that in the direction. So something was multiplied by negative 18 to get this number, and then the same thing was multiplied, same ratio was multiplied to get the fourth, and then this number was multiplied by that same ratio and came up with 2/3. Now, normally to find the ratio, we take the term behind it and divide it by this one. So let's just take the 2/3 and divide it by negative 18. And when we do that, we're going to have 1 over 27, but it would be negative. So the ratio to get from here to here is negative 1 over 20. If you take negative 18 and multiply it by negative 1 over 27, you're going to get 2/3. But the same thing was multiplied here and here and here. So 3 times the same thing was multiplied. So let's take the cube root of negative 1 over 27, and that's going to give us negative 1/3. So let's see if this works. So negative 18 times negative 1/3 would be a positive 6. And I'll just down here so you can see what's going on. So negative 18 times negative 1/3 is a positive 6. If I take 6 and multiply it by negative 1/3, I'm going to get a negative 2. And if I take negative 2 and multiply it by negative 1/3, I get a positive 2/3. So our common ratio is the negative 1/3. And they wanted to know the nth term. And so now that I know that it's 2/3, I just need to multiply by negative 1/3, and I'm going to get negative 2/9 as this term right here. Okay. Now, if they had asked, now find the 100th term, we could do that. But that's just kind of a little fun exercise to make your brain work a little bit. And this might be something that's on the ACT. All right, your work for today is on page 582. I want you to do number 4, 8, 12, 16, 20, 24, 28, 32, and 36.